Assalamu alaikum. Welcome to the project of Group 11. I am Sabiha Hassan Mim, student ID 23, and my partner is MD Rasul Khan Hamim, student ID 21. The title of our project is DC Motor Control. Our goal here was to implement the learning outcomes from our electronic circuits to laboratory for controlling the speed and duration of rotation of a DC motor. Our project is based on the process of pulse width modulation. Here we have produce varying duty cycles for controlling the speed of the motor. For higher duty cycle, we will get the higher speed, and for lower duty cycle, the motor will rotate in a lower speed. And for controlling the duration of rotation, we have implemented a H-bridge switching circuits. So let's now go to our circuit. The first part of our circuit is a wind bridge oscillator. Using this oscillator, we will produce a sinusoidal wave. So this is our sinusoidal wave produced from the oscillator. As we can see, this is not on the 0-volt reference. For this, we have added a DC offset to the circuit. So after adding the DC offset, here is our new outcome. So now our sinusoidal wave is with 0-volt reference. Then we have used an amplifier for controlling the peak. We have produced a 2-volt peak-to-peak sinusoidal wave, as we can see in the simulation, from -1 volt to 1 volt. Then we have used a comparator circuit. Here, this is our zero crossing non-inverting circuit. Using this comparator, we have produced a rectangular wave from our sinusoidal wave. So this is our rectangular wave from -1 volt to 1 volt, which means 2-volt peak to peak. Our next part is an integrator circuit. Using this integrator circuit, we have produced a triangular wave from our rectangular waveform. So this is our triangular waveform. For the next part of our project, will be presented by Role 21.
So the next part of our project is this part, which is an inverting amplifier by which we have reduced the amplitude of our triangular wave. As we will see its output, it is now a triangular wave of 2-volt peak to peak from -1 volt to 1 volt. After that, we have added an DC offset to the supply so that we get a triangular waveform of 2-volt peak to peak from 0 volt to 2 volt. We will use this triangular waveform to compare it. We will use DC voltage to compare with this triangular waveform so that we can use it to produce varying duty cycles. Here in the next part of our circuit, we have used an inverting amplifier, and here we have used a pot in order to produce varying voltages, varying DC voltages. So when I change the value of this pot, it will produce variable resistances, and as it is an inverting amplifier, the RF by RI value will change, and as a result, it will produce varying voltages, varying DC voltages, which we can compare with this triangular waveform. So as we can see, this is the output of our inverting amplifier, and it is producing a DC voltage. And after that, we have used an inverter circuit in order to invert that output. And this is our DC voltage, which we're going to use to compare. After that, this is our comparator circuit, in which we are comparing the DC voltage to the triangular waveform, and we will produce varying duty cycles. So here we have used the value of pot to 0.1, which will produce a smaller duty cycle. Here we can see our smaller duty cycle. Now, if we vary the value of pot, that means the value of resistance, and thereby varying the voltage supply, we will get different duty cycle. So by varying a pot, we have gotten almost 50% duty cycle. After that, if we vary the pot even more, we will get even higher duty cycle, and higher duty cycle will produce higher speed in our motor. So here we have gotten a higher duty cycle. So in this way, by varying this pot, we can produce varying duty cycles to control the speed of our DC motor. Now the next part of our circuit is an H-bridge switching circuit, which we have used to control the direction of rotation of the DC motor. Here in this circuit, if we close switch U11 and U12 and we open switch U14 and U13, then current will flow through this resistor from top to bottom. We have modeled our motor as a resistor here, and as we can see, if we simulate this circuit by removing these two switches, we can see the current direction, that the current is moving from top to bottom. And now if we remove the opposite switches, so now current will flow from bottom to top through this resistor. So after simulation, if we check the direction of current, we see that now current is flowing from bottom to top through this resistor. So if current flows in our DC motor in opposing directions, it will change the direction of our DC motor. So this is our circuit we have used to control DC motors. Thus, we are controlling the speed and direction of our DC motor. Thank you.